Imagine looking up at the night sky. You see the moon. It is familiar, it is comforting, it has been there for billions of years, a silent guardian watching over Earth. But what if that familiar celestial body decided to break its ancient pattern? What if slowly but surely our moon started to drift closer to us? This isn't just a thought experiment for a science fiction movie. It's a scenario that would fundamentally rewrite the story of our planet. The consequences would be profound, touching every aspect of life and the very structure of Earth itself. The gentle pull we take for granted would become a powerful disruptive force, reshaping our world in ways both terrifying and fascinating. Our moon is more than just a pretty light in the sky, it is a critical partner in Earth's cosmic ballet. Its gravitational influence stabilizes our planet's tilt, giving us predictable seasons. It also dictates the rhythm of our tides, a twice-daily rise and fall of ocean waters. This delicate balance has persisted for eons, allowing life to evolve and thrive. But if the distance between Earth and the moon were to shrink, this balance would be shattered. The familiar would become alien. The predictable would become chaotic. Let's consider what would happen if our closest celestial companion decided to pay us a much, much closer visit, and how Earth would respond to this cosmic shift in its neighborhood. Gravity. It is the universe's master architect. It is the force that holds galaxies together, that keeps planets in orbit around stars, and that keeps your feet firmly planted on the ground. Sir Isaac Newton famously described it, but its effects are felt everywhere, all the time. Between Earth and the moon, gravity is a constant, invisible tether. Earth's gravity keeps the moon locked in orbit, preventing it from drifting off into the cold expanse of space. But the moon, despite being much smaller, also exerts its own gravitational pull on Earth. This mutual attraction is the cornerstone of their relationship, a dance choreographed by the laws of physics. The strength of gravity depends on two main things: mass and distance. The more massive an object, the stronger its gravitational pull. Similarly, the closer two objects are, the stronger the gravitational force between them. If the moon were to move closer to Earth, the gravitational pull it exerts on our planet would increase significantly. This increased gravitational force wouldn't be uniform across the entire Earth. The side of Earth facing the moon would experience a much stronger pull than the side facing away. This difference in gravitational force across an object is known as a tidal force. Understanding this gravitational interplay is key to comprehending the cascade of effects a closer moon would trigger. Our oceans currently experience a rhythmic rise and fall, a gentle breathing pattern dictated by the moon's gravitational tug. We call these tides. High tide happens on the side of Earth facing the moon, where the water is pulled towards it. Interestingly, high tide also occurs on the opposite side of Earth because the Earth itself is pulled away from the water on that far side. This creates two tidal bulges. As Earth rotates, different parts of the planet pass through these bulges, resulting in the familiar cycle of high and low tides. Now imagine the moon significantly closer. Its gravitational pull on Earth would be much stronger. The gentle oceanic breathing would transform into a violent, convulsive sloshing. High tides would not just be a few feet higher, they could be tens or even hundreds of feet higher than normal. Coastal cities as we know them would cease to exist. These super tides would not be gentle lapping waves, they would be powerful surges of water moving with incredible force. The energy involved would be immense. The sheer volume of water moving back and forth would cause unimaginable erosion along coastlines, reshaping continents on a rapid timescale. The immediate consequences of these super tides would be catastrophic for coastal regions worldwide. We are not just talking about higher water levels, we are talking about the immense energy unleashed by these colossal movements of water. Imagine tidal waves, not the ones caused by earthquakes, tsunamis, but true tidal waves of unprecedented scale, scouring the land with each high tide. These would be like daily tsunamis, sweeping miles inland, destroying infrastructure, homes, and natural habitats. The retreat of these waters at low tide would be equally destructive, dragging debris and reshaping the landscape with ferocious power. The sheer force of these amplified tides would also exert incredible stress on Earth's crust. The daily loading and unloading of trillions of tons of water onto coastal land masses could trigger geological instability. Fault lines near coastal areas, already under tectonic stress, might become much more active. This could lead to an increase in the frequency and intensity of earthquakes in these regions. The immediate aftermath would be a world struggling to cope with relentless daily inundations and increased geological turmoil. The impact on marine life would be devastating and profound. Ocean ecosystems are finely tuned to existing tidal patterns, currents, and water depths. The extreme high and low tides caused by a closer moon would completely upend these delicate balances. Intertidal zones, which are nurseries for countless species and vital feeding grounds, would be subjected to conditions far beyond their tolerance. Many marine animals rely on subtle cues from tides for reproduction, migration, and feeding. Sea turtles, for instance, nest on beaches whose accessibility is determined by high tides. With supertides, traditional nesting sites would be washed away or rendered unsuitable. The entire food web of the oceans would be thrown into disarray. The influence of a closer moon wouldn't stop at the oceans and the crust. It would extend into our atmosphere, potentially altering weather patterns and climate. The massive movement of water during supertides would mean significantly more evaporation, especially in warmer regions. This increased moisture in the atmosphere could lead to more extreme weather events. We might see more intense rainfall, more powerful storms, and hurricanes fueled by the extra energy and water vapor. The increased geological activity, more earthquakes and volcanic eruptions, would also have atmospheric consequences. Large volcanic eruptions can inject vast amounts of ash and sulfur dioxide into the stratosphere. The atmosphere would become a more turbulent and perhaps a more hazardous place. One of the most profound long-term effects of a closer moon would be on the length of Earth's day and its rotation speed. Currently, the moon's gravity acting on Earth's tidal bulges creates a slight drag, which is very gradually slowing down Earth's rotation. This means our days are slowly getting longer, by about 1.8 milliseconds per century. The moon is also slowly drifting away from Earth as a consequence of this energy exchange, at a rate of about 3.8 centimeters per year. However, if the moon were to move significantly closer, this entire process would be thrown into reverse and dramatically accelerated. The much stronger tidal forces from a closer moon would exert a far greater drag on Earth's rotation. Instead of slowing down slightly, Earth's spin would begin to slow down much more rapidly. As the moon spirals inward, its orbital speed increases, and to conserve angular momentum in the system, Earth's rotation would actually speed up. Days would become shorter. This acceleration of Earth's spin would have widespread consequences. The entire biosphere would struggle to adapt to such a fundamental change in one of Earth's most basic rhythms. As the moon hypothetically spirals ever closer to Earth, there is a critical boundary it might approach, the Roche limit. Inside the Roche limit, the tidal forces exerted by the primary body, in this case Earth, on a satellite, the moon, become stronger than the satellite's own gravitational forces that hold it together. If a celestial body like our moon, held together primarily by its own gravity, were to pass inside Earth's Roche limit, the consequences would be spectacular and utterly catastrophic for the moon itself. Once inside this critical distance, the moon would begin to be torn apart by Earth's increasingly powerful tidal forces. The side of the moon facing Earth would be pulled much more strongly than the far side. This differential pull would stretch the moon, deforming it from a sphere into an elongated shape. As it gets closer still, these stresses would overcome the moon's internal cohesion. It would start to break up. Our familiar solid moon would disintegrate. The scenario of the moon moving closer to Earth, while a fascinating thought experiment, underscores the delicate balance that governs our planet's habitability. The moon, at its current respectful distance, is a vital partner. It stabilizes our axial tilt, giving us predictable seasons. It drives the gentle tides that have shaped coastal ecosystems, and perhaps even played a role in the origin of life. A closer moon would transform this beneficial relationship into a destructive one, unleashing forces that would reshape our world beyond recognition. From supertides inundating continents and triggering geological chaos, to a drastically altered climate and a faster spinning Earth, the consequences are dire. Marine and terrestrial ecosystems would collapse. Human civilization built upon the assumption of a stable environment would face existential challenges. Cherishing our moon as a distant, beautiful, and life-sustaining companion is perhaps the greatest takeaway. Let's appreciate the gentle glow, not the fiery embrace.